So, what is Pandas? So, if we just look at the Pandas site, you see here it says Pandas is a fast, powerful, flexible, and easy to use open source data analysis and manipulation tool built on top of the Python programming language. And the reason that you might have heard about this before is that it is often the tool that people will turn to when they're doing data analysis in Python. It's very full-featured, it can do a lot of things. If you go to the user guide, which is here, and I'll definitely be enclosing a link to this with the materials as well, this covers all the sorts of topics that you can do in Pandas. And at a broad level, what Pandas has abstracted is they've created this new object called a data frame. And that data frame has lots of different ways of like slicing the data, filtering the data, looking at the data. It's quite similar to kind of a Excel sheet that you can work with, but you can also do things you can't do easily in Excel, like merging two different sets of data into one, plotting these kinds of things. And all the data is better typed and you can validate it a bit more easily. And you can see here's sort of a short list of all the different things you can do. So you can view data, you can handle missing data, you can group by different columns and produce pivot tables. There's tons of functionality here. And I think in the video today, I'm going to basically run through some of the key functionality that we're going to be using as part of our work. But I would strongly encourage you to go look at this user guide, read the 10 minutes of Pandas, try and understand all the different things that it's possible to do, and use this as your base. And don't just use the videos. I think the videos are more about trying to demo the sorts of things that you can do. That being said, let me demo the sorts of things that you can do. So if you go back to our code here, so I'll get rid of the NumPy import for now, but if you just run this code quickly, you might find that on your machine, it initially has to install some packages to get this running. So just running the import will initially take about 5 minutes while it sets up your environment and downloads the Pandas package. Once you have that in place, let's go back to what we were working on before. So let's say we have some data, and we'll write it in this form for the time being. So we'll say child ID, which is, let's just do 1, 2, 3 for simplicity, and a legal status again. So we'll just do B1, B2, B3. I believe these probably aren't valid legal statuses, but they work for the purposes of demonstration. So again, if we just print out this data, we can remember how it looks here. So we get this dictionary with two lists, and we can index it to get the child ID, and we'll just get the data for child ID, for example. However, when the data's in this form, it's hard to get. Say if you wanted to loop over every child and just get a dictionary with one record per child, so it has like that child ID and that child's legal status. That's not so easy, and I think that's one of the tasks that Pandas kind of tries to solve, is it lets you take both views into the data at once. So to make a data frame, you can literally make it from this layout. So this tells Pandas all it needs to know to make this into a data frame. So let's make a new variable. We'll call it the df, so short for data frame. In fact, we can call this child, in fact. And then we can print out this data frame and see what the printout looks like. And you can see here that now we get a slightly different output. So you get the child ID, 1, 2, 3, like you'd expect, and the matched legal status, B1, B2, B3. And then here on the left, it's added an extra column, so kind of a index, where each row has a unique index within the data frame. And what you can do here is you can actually access all this information separately. So if you print out child ID.index and also, sorry, this would be child df.index and child df.columns. So both of these attributes will show you kind of metadata about the data you created. So if I print these out now, you can see that we get the index, which is described somewhat obtusely as a range index, start equals 0, stop equals 3, step equals 1. And then if I print out the columns, you can see that I get child ID and legal status. I wouldn't worry too much about the sort of larger types, because you can see here what they've done in the Pandas library is they've actually created kind of list-like types, but with some more kind of ways for them to manipulate them easily. So instead, to get these to print out in a more kind of traditional looking way, you can just call list on them, and that will return just two lists that look more familiar. So you can see now the index matches 0, 1, 2, that's the index, and the child ID and legal status columns match. What's happening under the hood here is that they come up with their own objects, but they all are objects which you're able to iterate over. And the kind of abstraction that all these things share in Python is that if it's something that you can iterate over, it's something that you can make a list of, because you can just go through everything in it in turn and get a list out. But that's quite a technical point, and in practice you can treat these like lists and they will work exactly the same. So how about actually accessing the data? So I think one of the interesting things about pandas is that you can do both styles of access. So if I do child df child ID, this will just print out this first column. You can see what you're actually getting here is what's called a series. So that's the other object that pandas provides. There's a data frame and a series. And again, you get the series values 1, 2, 3, but you also get the index 0, 1, 2, and then it tells you the name of the series is child ID, and it's of the integer type. Similarly, if I print out the legal status, you get the same thing. So the index matches, but you get the string. It's called legal status, and this is given the data type object because the string is just a kind of object. So that's how you can read out the same values that you already were looking at. However, what about this other method where you want to try and get the row by row data? So there's a few different ways to do that. One of the easiest ways is using the lock command or the ilock command. So I can write. So lock will say get me the record at index 0, and if I run this, I get child ID 1, legal status v1. And the same for the first record. I then get child ID 2, legal status v2, and so on. You can very similarly, you can use ilock, which in this case will be exactly the same. But the difference is this works. This is integer-based indexing. So the first row will always be 0. The second one will always be 1. The third one will always be 2. However, in some cases, your index might not match that integer indexing. In our case, the index is just, as if we go back to the view of the data frame, the index is just 0, 1, 2. So which one of these you use doesn't matter. You can also index more than one value. So like say that you want to find all the child IDs that are less than 3. So what you want is a data frame that only contains these first two things. So in order to do that, you can write child df child ID, which is the child ID column, is less than 3. And if I print this out, what I'll get back will be just the first two. So, I mean, probably it's helpful to have these side by side. So you can see here that what we've done here is essentially filtered. So I think that this is quite a key point, and this is actually one of the key skills that I think you'll be using throughout this sort of creation of these rules, is being able to apply these filters across various different columns and use them together. So I think it's worth understanding a bit more about what's happening under the hood here. So in this case, you've got this inner expression, child df child ID less than 3, and then this outer expression, which is saying to index by this. So let's look at just what this middle expression looks like. So we can print that out here. And it should be print a second. So you can see here that, so that's the original data frame, print child df. And then you can, let's clear that out of the way. You can see here, so what you actually get by doing this is you get a new series where the values are true, where that holds, and false otherwise. So then what's actually happening here is something called Boolean indexing. And what this means is that basically if I pass a list to the index here, so if I just go back to this and instead just wrote true, true, false, this will get interpreted as show this, don't show this, which translated here is show 0, show 1, but don't show 2. And you can see here again that filtering occurs. And the same thing, so if I flip to false here and true at the end, we get 0 and then 2. So all this, so really there's kind of two separate bits that cause this indexing to work. You have to get this list of true false values, and then that has to get passed to this indexer to build the whole index and be able to see those values within the data frame.